So this is Unpacking K-5 Math for Caregivers, and today we are going to talk about why mathematical language matters for parents who are home with their students, with their kids when they're home, I guess they're kids. So I'll just start with a comment that when I watched our prior episode, our first episode, my own language surprised me because we were very informal, and if I were home with my kids, I wouldn't speak that way to them when they're trying to learn certain mathematical concepts. So I said many times in that video 478 instead of 478, which was the number we were working with. And if a child is trying to learn how to call the numbers or the numerals, and we are using imprecise language at home, that I think that is, well, it's not a problem, but it would help if we used language. So ideas on using precise and mathematical language at home.
Well, I'll jump up into what you just said, right? So you just made a distinction between a number and a numeral. And this one's not critical for a caregiver perhaps, but it's something you'll see kids try to learn the language for those things. So a number is the actual quantity of something, and the numeral is the representation that represents that quantity. So 37 is the numeral for 37. But it represents 37 things, and that's the number. And then finally, there's digits inside numerals. So it's important for kids to understand that 37 is a 2-digit number, and that those digits have meaning. So as you pointed out, for 478, it's 478 because that 4 is a digit that represents 4 times 100. So just real quick, number is the quantity, numeral is the written form, and digit is inside the numeral, you have digits.
Yeah, so I noticed several times, and again, I think for adults, it's okay because we talk like that all the time. But if you're home and your student is learning place value, is learning about 3-digit numbers, your language as a caregiver should be precise. I was thinking of other situations where I, for example, say 4.25 all the time, and we don't say 4 and 25 hundredths, which is the correct nomenclature for that number. And again, for adults, I don't think it matters, but if your child is learning tenths and hundredths, and that's what's happening in school, using the proper language at home, I think helps. I'll give you one more example that I've been thinking about that, you know, I hear all the time. Oh, that's an upside down triangle. You know, when parents are referring to a triangle where the point is not to the top, but that doesn't exist in math. That's just a triangle and not a usual orientation. But it's really problematic when we say those things at home. And I think for caregivers to try to pay attention, what is your student learning? Where are they in their mathematical language, and how to be precise is real helpful.
And I was going to piggyback on what Valerie was talking about when we think about the number versus the numeral versus the digit, and thinking about those ideas around place value. And especially right now, if you're working with your kids at home, in terms of a tip for a caregiver, if you're working with them on operations, to try to use the values of the places when so if you're thinking about, instead of using the language that maybe we were taught to use about carrying a 1, then instead what's happening there, say if you're adding 38 plus, I don't know, 48, that when you add the 8 and the 8, you get 16, that you have the 6 ones, and you're regrouping that 110 rather than saying carrying a 1. So again, just trying to be trying to be precise in our language when we talk about operations as well, even if it's around a more you know, what we might call the traditional algorithm like we learned when we were children.
Oh, Valerie, you are muted.
My dogs were barking. So let me just reinforce what Temple just said. And just, yeah, so she says 38 plus 48. We tend to say, you know, put the 6 here and carry the 1 rather than saying, well, 8 and 8 is 16. So we have to think about how we're going to decompose that for our algorithm. We're going to put our 10 up here. And because it's in the tens place, we can just write 1 because that means 110. So again, sort of explaining that. And,
Well,
and go ahead.
no, and even in that algorithm, then instead of saying 1 plus 3 plus 4,
That's right.
it would be better to say 10 plus 30 plus
30 plus
40,
40. Mm-hmm.
you know, and that is 80.
Yes.
Yeah, and it might even, and you could even add to that that you're adding 110 plus 3 10s plus 4 10s, right? You could talk about it in both ways, and that's 8 10s that you have, which is equal to 80. You know,
Right.
both ways would be a nice, precise way to talk about it. What you said, Paula, and then the other way.
Yes, and culturally, our habit is to not make that clear. So that's one really nice way that you are teaching place value while you're using precise language allows you to teach more than one thing at once, right? So I'm not just teaching the algorithm, also reinforcing ideas about place value. And this goes the other way too. So a thing that will happen sometimes is, let's say I've got 25 and I'm taking away 8. What will often happen is that you'll hear people say, well, I don't have enough 1s. So, you know, I've got 25 minus 8 and I'm in a pickle here. I don't have enough 1s. But that's problematic language because you've got 25 1s, right? And so when we habitually say we don't have enough 1s, kids really start to see 25 as 2 10s and 5 1s and nothing else. And that's that flexibility we spoke about last week. So we need to say, well, in this form, I don't have access to my 1s. That seems like a big thing to say, but it's accurate. And so if children hear that again and again, they start to understand, oh, I have enough 1s. I just have to put them in a different form. And I have to think about 25 as a 10 and 15 1s. And in that form, I have the 1s I need to take away my 8 1s.
Yeah, so I am wondering how much caregivers who are not in the day-to-day of the classroom are thinking about these details, but it is really important to make sure at home we are using the precise language whenever possible and accessible to the family. Another one that I make that mistake all the time is the use of the and when I'm saying the numbers. You know, you should really save the and for the end of, for when you're done with your 1s. So it should be 475 and 3 tenths, let's say. But we typically, many parents would say 475 and 3 tenths, when really we want to save that and to indicate the decimal point. But that's another place where when I'm not paying attention, and I'll say whatever, I'll say 4 and 78, you know, it's 478 and I just said it, whatever, you know, oh, it's 4 and 78. So I think that's another place where we could be careful with the language. I was trying to collect examples and think about situations when we are imprecise. I like the algorithm one too, Tempo. It's really an easy way to provide more meaning when you're talking about math at home.
And, you know, another thing that comes to mind for me when I think about for caregivers would be for if you have upper elementary students and they're doing more work with fractions, you know, I think sometimes in everyday language, we might say things like 1/4 or 3/4, because the 3 is over the 4 positionally, but that doesn't really make sense of like the actual unit and really thinking about, you know, 1/4. And actually, I'm making a connection right now when I think about when we were just talking about those 10s that were being added together. you know, that again, around that, what's the unit? And maybe I'm talking beyond thinking about caregivers, but I'm thinking about, you know, 1/4, 2/4, 3/4, that their unit is the fourth. And just being really careful with our language around fractions as well. I don't know if either of you want to add something to that.
Well, only that either that we'll probably talk about this in later episodes, but this idea of counting, that we can count by ones, we can count by fourths, we can count by tens, and it's really important to include our units so that students start to get this idea that I can count by any unit. Now, when I count, I have to count the same size unit, right? But I can count in any unit. So that's another thing when it comes to thinking about precision in language, is making sure you're talking about the unit, what unit is happening at the time. Even as simple as when you're working with your students at home, if there's a word problem, a story problem, and the answer is 7, always saying 7 what? 7 balloons, you know, 7 pizza pies, like 7 what? Another thing that I think is pretty easy, I think, for caregivers to think about is what it means to be equal. And so what we grew up learning is that equal means same as, and that's inarticulate. Equals doesn't mean same as, because same as means the two things are the same as each other. And equals really means same value as. So things can be in very different forms and still have the same value. So if I have, you know, even something like the square root of 9, we know equals 3, but you write those things for different reasons because they mean something different. They are the same value, but they're not the same form. So they're not exactly the same as each other. If you think of equality as an attribute, you get the idea. Just because two things are blue doesn't mean they're the same as each other. Just because two things have the same value doesn't mean they're the same as each other. So that can be confusing for kids, because if you say that 3 and 2 are the same as 4 and 1, they're not, right? Right? They would represent different things in a story problem. They look different, but they do have the same value.
So I'm going to take us back to that discussion of efficiency, because I think that is key for me for some of these things, and even some of the language we use. So I think in math, we like to be tighter and tighter. You know, the more packed our language with meaning, the better. So we want few words that mean a lot. And I think that's okay for adults, but for kids, it's problematic. And so equal, we know what it means. It means equal. It doesn't mean they are exactly the same. It just means they have the same value. But if we don't articulate the language properly when you're learning, that's the problem. The kids, early on, they're learning these things, so they cannot have yet that language that it's so concise. So I think as an adult, it's okay that when I have 16 in my ones place in my addition, I put the 6 in the ones place, and I put the 1 in the tens, and I say 1 + 2 + 3. Because I know already I'm doing 10 + 20 + 30. But when kids are learning, you have to be unpacking that and articulating in your language. So I think that's perhaps what caregivers have to be thinking about. It's different for you as an adult. You already know this, but your child is just learning. So your language has to say, this is the same value as, this is 10 + 20 + 30. This is 475 and 3/10, which we would say 475.3, which is okay for adults, but not for kids when they're learning it.
That's a really nice point. And that goes back to this idea of, as teachers of children, we're always thinking about both the child development and the mathematics. And so we're just asking caregivers to sort of give a nod to that too.
But it's hard, right? Because even I knew we were going to talk about, then I start policing myself and realizing my language is very imprecise. But, you have to make the effort, I think, if you want to support your learner. So any final thoughts on this issue that we think it's important, or any ideas on how to support caregivers?
I think, for me, an initial first step, I feel like when we think about K-5, that probably a lot of parents right now are working with their students on operating on numbers. So I think that might be a place to start, to just being careful about your language when you're grouping, regrouping, and all of those types of things, about what you're saying in relation to thinking about specifically place value.
Can you give an example? Just what we spoke about earlier? Is that you're just reiterating that?
Yeah, I'm just reiterating that. I could provide other examples, but maybe that's for another video cast when we maybe unpack algorithms, because we could really unpack the traditional algorithms in the United States, and maybe in one of our video casts.
Okay. All right. I just want to make sure. Okay. So,
Yeah.
So the first thought then is this idea that when you're doing addition or subtraction or any algorithm, that you're thinking about the value of the numerals and the value of the digit, and stating them precisely.
Yes.
Yeah.
That's what I was intending to.
And I'll just stick with my equality. So just be careful not to say same as. You're working with young kids. Say, oh, it is. Oh, yeah, those two things are different, but they still have the same value as each other. I would stick with that.
Yeah, and I think one idea I would say for caregivers, actually do take a look at your students' textbooks, because we don't remember either. So it might be worth looking at what the textbook or the online materials, if they say something about this topic, just take a look to remind yourself of how many simplifications you've made over the year to your language, to a point that it's no longer precise, but it's okay for an adult, but not helpful for students. And with that, I think we'll say goodbye.